the Dirac delta function in 3 dimension. In 3 dimension, the Dirac delta function is del cube r equal to del x, del y, and then del z. And as always, r equal to x, x hat, plus y, y hat, plus z, z hat is the position vector extending from the origin to the point x, y, z. And as in the previous case, the 3D delta function is 0 everywhere except at 0, 0, 0 where it blows up. And its volume integral is integral in all space del cube r d tau equal to minus infinity to plus infinity, minus infinity to plus infinity, minus infinity to plus infinity, delta x, delta y, then delta z, dx, dy, dz, which is equal to 1. And also in all space, fr delta cube r minus a d tau will be equal to fa. That means that as in the 1D case, the integration with delta picks out the value of the function f at the location of the spike. We may now revisit the paradox that we encountered in calculating the divergence of r hat over r square. We have seen that del dot r hat over r square is equal to 0 everywhere except at the origin, and yet its integral over any volume containing the origin is a constant and which is equal to 4 pi. In defining the Dirac delta function, we make use of this observation. That is, del dot r hat over r square equal to 4 pi del cube r. Or in terms of the separation vector r script, which is equal to r hat minus r prime, this equation becomes del dot r hat over r square equal to 4 pi del cube r. Note that the differentiation here is with respect to r, while r prime is held constant. Also, since del over 1 by script r equal to negative of r hat over r square, we have del square over 1 by script r equal to negative of del r hat over r square, and this is equal to minus 4 pi del cube r. Based on the discussion we had, let us try to calculate integral r square plus vector r dot vector a plus a square del cube r minus a d tau, where vector a is a fixed vector and a its magnitude, and the integration is over all space. We have integral over all space f of r del cube r minus a dτ equal to f of a. This gives us integral r square plus r dot a plus a square del cube r minus a dτ equal to a square plus a dot a plus a square, and the answer is 3a square. The second problem is to calculate integral r raised to 4 plus r square vector r dot vector c plus c raised to 4 del cube r minus c dτ, where v is a sphere of radius r about the origin and c equal to 5x hat plus 3y hat plus 2z hat, and c is its magnitude. As before, let's begin with what we have in our hand. When we calculate FA equal to c raised to 4 plus c square plus c raised to 4, and c square is 5x hat plus 3y hat plus 2z hat dot 5x hat plus 3y hat plus 2z hat, and this is equal to 25 plus 9 plus 4, which is equal to 38. And we see that c square itself is greater than 6, where 6 is the radius of the sphere having volume v. So we understand that c is outside v and the integral is therefore equal to 0. Problem 3 is to evaluate the integral j equal to integral over a volume e raised to minus r del dot r hat over r square dτ. Therefore, we have j equal to integral v e raised to minus r 4 pi del cube r dτ, where we have substituted for del dot r hat over r square to be 4 pi del cube r. This is equal to 4 pi over volume v e raised to minus r del cube r dτ. This is equal to 4 pi times f of 0, where e raised to minus 0, and that is equal to 4 pi.